Welcome to What to Ask Before You Build, advice from Green Building Pros. My name is Jessica Hunter, and I will be leading our panel discussion this evening. We have many viewers here tonight that are attending their first Colorado Green Building Guild event. Welcome. CGBG is a Boulder County-based nonprofit organization founded in 2004 that brings together builders, designers, product manufacturers, engineers, and real estate professionals that are committed to or interested in green building. We are here to provide resources, education, and networking opportunities to our members and provide leadership in our community. Please remember, we are a small organization run by volunteers. We will do our best to answer your calls and emails, but it may take us some time. We want to thank our sponsors for helping us continue this work. We truly appreciate your support. Our sustaining sponsors include Louisville's own window manufacturer, Alpine High Performance Products, who have been a long time national leader in window technology. They are joined by 475 High Performance Building Supply, a resource for both quality building materials and a ton of educational free resources. Our supporting sponsors are Boulder County, Hammerwell, Cottonwood Custom Builders, Caddis Collaborative, and Floor Systems. The best way to keep up to date with all CGBG events and information is through social media, our emails newsletter, or by visiting our website. However you prefer to stay tuned, this is where you'll find us. For those of you who don't know me, I'm an architect, a local Boulder County resident, and the president of the Colorado Green Building Guild. My family was first impacted by fires in 2017, and since then my aunt and two of my sisters have lost homes to urban wildfires. I've also helped homeowners in the aftermath of these fires in my role as an architect. I've listened to their stories, struggled with their insurance, and helped them weigh their options for how to move forward. I was not directly impacted by the Marshall Fire, but I hope that my previous experience can help inform our discussion tonight. I am joined by 5 panelists, each of whom I hold in very high regard. They are leaders in their field and in this community. They've each been involved in building high performance homes and in the dollar and cents realities of these choices. Mark Attard is joining us from Hammerwell, a local high performance home builder. He has been part of the passive house community since 2008, and in recent years has been applying his knowledge of passive house strategies to his own home in Louisville. Mark, thanks for joining us tonight.
Thank you very much. I'm appreciative of the time and hope that we can be helpful to those who are listening here tonight and provide some measure of understanding of high performance building and all the surrounding issues.
Absolutely. Also joining us is Greg Fisher. He is an architect in Fort Collins who established his firm in 1993. He has been involved throughout the Front Range in numerous sustainability-driven organizations and boards. He won the CGBG Green Champion Award in 2020 and led an educational series for victims of the High Park Fire in 2012 and 2013. This past year, Greg completed his own passive house, much of which he built himself. Greg?
Thank you. It's very nice to be here. I wish it was under different circumstances, but hoping that this is helpful and potentially inspiring to folks.
Thank you. Mariana Pickering is the co-founder of EMU Systems, a team of building science educators. They help us understand the science of how buildings operate and how to make smart and buildable homes that are healthy and comfortable. She started her career as an architect and then realized she could make a much larger impact by training and providing resources to the building community. Mariana won this year's CGBG Green Champion Award. Mariana.
Thank you. Yes, I'm very happy to be here. We train builders all over North America and Australia, and I can say this is definitely a global concern, how to address the impact of wildfires and bushfires. So I believe in shared resources and shared knowledge. Hopefully we can do that today.
Thank you. Brian Fuentes is a local architect and certified passive house consultant. He has lectured at the University of Colorado, for the Department of Energy, for the Colorado Renewable Energy Society, and for many other organizations, including ours. Brian is passionate about reducing the built environment's energy use and has been committed to all electric, zero energy homes for over a decade. He and his family lived in Marshall. Their home was destroyed by the fire. Brian, we really appreciate you making the time to join us tonight.
Well, thank you, Jessica, for the excellent introduction for everybody. And hopefully all of our experience and knowledge will be helpful to people here tonight.
Andrew Michler has focused on high performance building design and materiality since 1993. He is an author, the co-founder and current board member of Passive House Rocky Mountains, and has served as chair to the Northern Colorado Renewable Energy Society. He completed the first international certified passive house in Colorado in 2016, which has won several awards. Andrew?
Thanks, Jessica. I guess you guys probably have noticed the theme so far of passive house experience amongst us, but it's really great to see the Colorado Green Building Guild, the County of Boulder and the cities and even the state come together to help kind of participate in developing kind of these high quality formats for information for rebuilding. So
Thanks, Andrew.
Look forward to the evening's proceeds.
Yeah. Our discussion tonight is structured around a list of 10 questions in no particular order to ask before you start building a home. While this event was created in response to the Marshall Fire and for the benefit of the many homeowners looking for resources at this moment, we hope that this presentation can also inform anyone, anywhere preparing for their own project. We will stay focused on big ideas, but be following up with monthly events dedicated to diving deeper into these topics throughout the rest of the year. These events will remain free, regardless of membership, and will be recorded and available on our website and our YouTube channel. It is important for us to be very clear. Buildings are complicated. Each decision you make will impact everything else around it. This is why we encourage all homeowners to find a team that can lead you through that building process so that you can make the best decisions for you and your family. You can all ask questions during the discussion in the chat feature. We have a full presentation planned, but we'll be opening the conversation to Q&A at the end. I will be reading these questions aloud and we'll get to as many as possible. Lastly, please know there is no one on this panel who is participating tonight for any personal or professional gain. We are here because we care about the future of this community and we want to share the knowledge we have with you. Let's get started. When you build a home, you will make a million decisions. And that isn't an embellishment. There is no standard off-the-shelf home, not even in a large development, not even in a big apartment building, no standard. The most important decisions you will make are the ones the most difficult to change later. We hope you can keep an open mind and ask yourself, what kind of home do you want to live in? We're going to start with Greg Fisher and the question, what natural resources do you already have?
Thanks, Jessica. Before I dive into that, I'd like to say just a couple more things. Again, I'm very sorry for all of your losses. I can't imagine what you all must be going through. My only real exposure to this is through the Hyde Park fires, which occurred almost 10 years ago now, north of you all. And there was a similar effort to what CGBG is trying to do right now, formed around that Hyde Park fire event, and I participated in that. And I remember the early meetings that we had and how scary it was for everybody on both sides of the conversation. You know, those that wanted to help and those that needed to help. And of course, those that needed to help were dealing with so many more things than buildings. But I saw that group come together over time and really help each other. And now it's been almost 10 years, like I said, and so many of those people have rebuilt now and are back in their homes. And it's probably pretentious of me to say this, but I think many of them are better off for the process and are in better homes. And I hope that it's too early, I know, for all of you to see it that way, but I hope that at some point in time it will be that sort of experience for you as well. I can also speak firsthand to building a home, as was mentioned, just moved in about a year ago into a new home where was not only the architect like I normally am, I was also the homeowner and the builder and the framer, etc. And so I know the trials and tribulations of building can be pretty challenging, but I also know the rewards can be very great, not only for when you move in, but for years and hopefully generations to come. So moving back into the topic, what natural resources do you already have? I'm guessing that this may not be true for all of you, but there was probably some reason that you were drawn to the home that you had when you first moved there. And hopefully maybe there is some piece of that remains, be it a view, be it proximity to something else, or just the spirit of the place. And that, our hope would now be to try to optimize those things that you already had and maybe enhance them with other aspects of good design. And so like many things we'll be talking about tonight, there are things like this particular subject, proper orientation in building form, that just giving adequate thought and care and concern and education and knowledge to doesn't cost you any more to improve your end result. It's just being conscious and careful about it. And definitely, orientation and site planning are one of those things. So when we talk about site planning, particularly for passive design, one of the first things we think about is how can we best capitalize on the sun? How can we get the most amount of sun in the wintertime? And how can we keep that same sun out in the summertime so that we're not overheating? And so we start with trying to orient our windows properly and trying to orient our sun protections properly. So we want to basically try to increase the amount of glazing we have on the south side of the house. We want to diminish the amount of glazing we have on the north side of the house. And we also want to try to control the amount of glazing we have on the east and the west sides, because they're harder to control the sun from coming into in the summertime. So in the wintertime, the sun is low, and on the south side of the house, we can put overhangs in, and the overhangs don't block the sun from coming in the windows, whereas in the summertime, when the sun is high, the overhangs do block it. But the east and west sides are more difficult to control because the sun is always lower on those sides. So it almost becomes more practical to use a vertical fin approach versus an overhang. So in general, we try to, purely from a passive standpoint, try to minimize the east and west exposures and increase the south. So if you could elongate your house east to west, that's an ideal thing. Of course, there are many other variables that you have to compromise around to do this. And so particularly in the Front Range here, most of our views are to the west, not always, but often to the west. And so that means maybe you want more windows on the west side than you would from a purely thermal or passive standpoint. You also have to think about, what is your orientation to the street and the approach and so forth. And so basically you have to meld all of those things together. You also want to think about the rooms that go into the house and where they are. For example, in an ideal scenario, it's best to put your bedrooms in your garage on the north side of your house and use that as a buffer to protect the rest of your house. But again, of course, views and orientation to streets and so forth may not allow that, but those are things definitely you want to consider. When we talk about site planning, we also want to try to capitalize on the on-site renewables if there are those available to you. And so certainly the first on-site renewable we think about is solar, and in the form of both photovoltaics and solar, hot water, more PV these days than hot water. And so we want to make sure that we've got adequate amount of roof space that's properly oriented to receive the sun. So we want to have more roofs that are south-facing slopes if possible. East and west also work. Even a low slope, north-facing slope can work as well. It's just not near as efficient. And so when you think about those roofs, you also want to think about what kind of plumbing or other penetrations are going out that roof so that you're not interfering with your future potential for solar panels or your current potential for solar panels. You also want to think about what's the surrounding context. So, if there are tall trees, particularly evergreen trees or hillsides or something that block your access to the sun, you have to weigh that in the conversation. And if you ultimately decide that or discern that you do not have adequate solar orientation, you may want to think about participating in a community solar garden, where the solar panels are off-site from your house and you purchase the rights to use the power from those solar panels. We also think about geothermal systems when you're talking about on-site renewables. And geothermal is basically, taking advantage of the 55-degree temperature that's in the earth year-round. And so we run piping down into the ground and basically try to draw that heat out of the ground. So we're taking that 55-degree temperature out of the ground in the wintertime, and then we're amplifying it up to use it to heat your home. And then in many cases, you're also able to push the heat out of your home in the summertime down into the ground and use that for cooling. Not all cases because of humidity concerns and condensation concerns, but many concerns. And so again, something to be thinking about ahead of time. And another thing about geothermal is it's often perceived as quite expensive, and it definitely does have higher initial cost. But there are many tax incentives and other incentives out there that offset a large portion of that. It's also very intense staging and mobilization costs to get geothermal wells done. And so if you can potentially come together as neighborhoods and try to hire contractors that can perform that work as a group, you can possibly save some money as well. We'll stop there for now and allow for Mark.
Thank you for that. It was an amazing amount of information, and I know it's probably overwhelming for people who are homeowners and are just thinking about where the sun moves during the day and throughout the year. What do you think that are the easiest? Every site is different, and your connection to your neighbors and to your views is always very important. But are there is there anything that homeowners can try to do low cost besides that site planning to help set themselves up for future ideas like on-site renewables specifically? There's always an initial investment, but you don't have to make that full investment now.
Yeah, I mean, I'm not sure if this is exactly getting at what you're saying, but one avenue with solar, speaking to that specifically, is if you allow to have your roof set up that you could have those panels in the future, all you really need to do at this point in time, if you're not able to put forth the capital to buy those solar panels, is basically get conduit run from your electrical source in your house, your electrical panel, up to the roof and to the outside where you can have future gear mounted to feed that. So you can have pretty minimal expense to get that future solar capability.
Thank you so much. Our next question that we think you should ask before you start a building project is, where can you save real money? And I know this is something on everyone's mind, and to Greg's point, kind of a great bridging point. Mark, I'm going to let you take over.
Great, thanks, Jessica, and thanks, Greg, for your comments. Saving money is always an interesting thing in building because as was mentioned previously, there are many different decisions that have to be made, and all of that can impact the bottom line dollars that you're looking to spend on your project. But there are some basic areas that we can take a look at that really do impact cost. And the first one is just the general size of your home. As design has developed over the years, we've found that you can actually look at a home that's a little bit smaller that works just as well as a larger home. And I've mentioned this because that size directly relates to the cost of your home. If we build a bigger home, it's going to cost more. There's just no way around that. If we build a smaller home, it's going to cost less. And it's just directly related to the amount of materials and the amount of work involved in building a larger building. The other aspect of it that we want to look at is, what does that home look like? Many homes that have been built in the past have a lot of corners and jut outs and cantilevers. All of these things add to the cost of a home. And it's important to take that into consideration when you're looking at the design of your new home. Is it really beneficial for you to have this cantilever or to have multiple corners, or can we accomplish the same size and feel of your home by simplifying the design and making it a little bit easier to build? Along with that, basically the rule of thumb is the more corners, the more cost. If we are adding more corners, we're adding complexity to design, which requires the builder to look at that design from a different perspective than if we're dealing with a more straightforward design. That being said, that doesn't necessarily mean that your design has to be blah or just vanilla. There can be a lot of dynamics in that design that don't necessarily add complexity. The other thing that we want to take a look at is just what can you do now versus what can you do later. One of the things that's important to understand about Passive House and high performance building is that we are looking at the core values of the house, meaning what are those walls, how are those walls performing, how are those floors performing, how is that roof performing, how are those windows performing? And the reason why we look at those is because those are things that are likely to change in the future. But there are many other things that add cost to a project that we don't necessarily have to implement now, that we can wait for into the future to implement, and that we can prepare for into the future. So those need to be taken into consideration. And really, we need to assess the values of the house that we're building and decide what's most important. The idea here is that we're trying to build efficiency in that's going to last a long time. And then we can go ahead and we can add on all the other things at a future date, if in fact that is necessary to make your budget work. And then lastly, I think what we really want to look at is we want to look at the team that you invest in upfront. It's really super important that we bring a team together that understands the goals that you're trying to accomplish in your home, and do that in a very, very immediate and in a time frame that is at the very, very beginning of your design. It's much easier for us as builders to go ahead and develop budget and value engineer as design is happening and as we are working with that architect to meet the goals that you are trying to meet for your project. If we're handed a set of plans and then we're asked to execute, we have less opportunity to really value engineer and to affect design and affect overall performance. So if you bring your team together soon and they're working together in conjunction with you, not only does it help in terms of the cost of the project, but it helps in terms of the time frame. We can get the project off the ground sooner because we are advancing design decisions almost in real time, if you will.
Thanks, Mark. I think, you know, what we're talking about here, and you make so many great points, is that the guts of the building, the part of the building you're never going to see again as a homeowner, do so much work for you. And whether you have one kind of siding on your house or another, or one kind of millwork in your house or another, has a larger cost impact than some of these other pieces that really impact the efficiency of your home and will stay over the long term, where these other projects can be added to over time, etc. We will keep this moving to question number 3. Andrew is going to speak to this question. How can we invest in resilience?
Great, thank you. Hey, Johnny, do you think you could share screen? I actually made a little slideshow because I think it's kind of a visual problem. If not, that's not a big deal. And I want to just say that, so kind of just my quick background is that my first experience with building was actually the Oakland fires in 1991. We lost about 3,200 homes, and one of my house was one of those. So that's where I started learning how to build things. So, you know, it can change your career, it can change your life path, these things, these events. Right now I live in the woods in kind of a Wooey area for about 25 years. And last year, the Cameron Peak fire came through our neighborhood and took out about 11 homes. I've been talking and thinking about fire resilience for a really long time. And unfortunately, there's not a lot of resources out there, and code doesn't necessarily track with fire resilience, at least when we talk about wildfire events, as opposed to interior fire events. So let me share a screen. What I'm going to start with is the idea of, first of all, is that I won't read this, but code changes in California since the Oakland fire and onwards has had a pretty dramatic measurable effect and immediate effect on the survivability of housing within even urban areas for wildfire. So we're seeing dramatic effects just by simple changes in how buildings are designed. And I'll go through some of those details. The first way to think about is to think like a log, not like a stick. And yeah, I know a lot of you probably have started a fire, and we know that the first thing is you can't set a match to a log and set it on fire very easily. We're talking about resilience. We're not talking about fireproof. So it takes a long time to start a log on fire, but a bunch of sticks, take much less time and much less effort to start. So that's kind of the first kind of visualization of how to design a home. And to what Mark said is start with simple design. The simple design keeps the embers or kind of the fire front from embedding in little corners and crevices of your home, especially a more complex home, the more places for flame and embers to embed themselves and to ignite. And it's a pretty extreme event, as we now know. And so thinking about how houses survive that can take a little bit of imagination on the dynamics of it. But when you start seeing the way that fire flows through or around space, we can actually anticipate that and design for that. Think of things that lead up to the house. This is actually one of the most critical aspects for fire resilient design, is these large wood decks that are popular in Colorado. Of course, we have incredible weather, incredible views. We like to spend time outside, but we put these giant piles of sticks next to our houses, and they are the first to go, and they act like a wick. Even fences, there's lots of photographs of fences that lead a fire. Doesn't touch anything else, but the fire burns along the fence right up to the house and ignites the house as a result. So it's very vulnerable. Landscaping, having the type of greenery that's very prone to flames, high temperature things such as what do you call it, like a juniper plants, things like that can be quite dangerous. And honestly, and we found this over and over again, houses next to other houses is often one of the main ignition sources. So once we build entire neighborhoods, they're much more fire wise. They call them Firewise neighborhoods. The much more protected the entire community becomes. And so this is implemented in places like Colorado Springs. Resilient design or Firewise home, it means mind the gaps. So little things become big things. For instance, the ventilation system to your roof is one of the fastest ways for embers to come into a very vulnerable part of your house, your attic space, and then burn your house from the inside out, from the top down. So for a Firewise house construction, we really look at things like the details around the eaves. We don't necessarily ventilate underneath the roof. This is complex with current code, and there's a lot of conversations that need to happen during that design process. And code certainly needs to conform to some of these realities, I think. Greg can speak to that, I think, in some detail in the future. But the Firewise building structures are closed to letting air just simply wash through to the interior of your building structure and allow embers into that space. Windows are a very vulnerable place in buildings too. It's quite stunning that you can, some other of the fires, Greg talked about a fire from 9 years ago in the neighborhood that's near me, and people built concrete houses that burned in that fire. And the reason is not just the roof, but the windows failed. So the fire cracked the windows from the heat, basically. And especially double pane, single panes, of course, you can't build with that anymore, but a lot of people build with double pane windows. And it only takes about 3 or 4 minutes in a high intense heat environment for a window pane to crack. For long exposure, say a house next to it is burning, that can lead to 2 panes cracking, which can lead to an open space for the embers to get into the house and again, burn from the inside out. So we recommend the idea of using a triple pane window. We're passive house people, so we're kind of used to using triple pane windows, but that adds another 50% of resiliency. And if it's tempered, then tempered glass is actually very resilient to high heat. So your windows basically become fire resilient at that point. Wood around buildings. Wood is a fantastic product, but given kind of the new conditions that we live in fire-prone areas, wood is highly susceptible on the exterior buildings for fire. So unfortunately, window shakes are kind of out of the question typically, but we can make fake shakes out of cement board. Brick is quite popular. Metal is used quite extensively in fire resilient areas as well as stone and stucco. Stucco that's against materials that are also fire resilient. And that means that not using foam on your buildings, especially on the exterior cladding. I've heard people talk about foam as like a liquid gasoline, or I'm sorry, solid gasoline, that it goes up quite quickly. And even with fire retardants, it's quite susceptible for fire. So if putting a stucco barrier, like one of these metal barriers onto a foam substrate is not necessarily a fire resilient building structure for best practices. That includes spray foam. And unfortunately, something like a fiberglass insulation, fiberglass has a low melting point and also lets quite a bit of air through relatively to other insulation products. So it actually can encourage air or oxygen feeding through wall systems. So we often recommend something like a mineral wool board. Mineral wool board on the exterior is fantastic. Mineral wool on the inside of the walls is also fantastic. It basically will not burn in a fire event, typically. Cellulose, we hear about cellulose as a paper product, but they use borite. And when it's called dense packed applied, it doesn't let any oxygen through the wall system. So it creates a pretty good fire barrier as well. And these are typical products you can find in standard for construction. Air tightness is, I think Mark Attard can go into some detail about how important air tightness is for buildings in fire events and for air quality assurances. So we try to do an airtight, resilient, or I should say dedicated airtight barrier in a building. And then we make it tight and ventilate it right. You may hear that term thrown out quite a bit in the future. And so we encourage people to put in dedicated ventilation systems that also exchange heat with the building and sometimes moisture. But basically this ventilation system is a standalone system that we can shut off during extreme fire events, but also typically during kind of like further events, fire events further away, we can put in filtration and control the quality of the air coming into the building. So that's it for the idea of just kind of a quick scenario on what Firewise construction looks like nowadays in the state of the art. And there's certainly a lot more in the dynamics of fire to go through, but it's something that we can actually design for and see good results from.
We can. Thank you, Andrew. I think we're going to have you back for a dedicated conversation just on Firewise. I know in the first fire I went through, the there's the wave of fire, the mass of fire, but what was happening was that large embers, I mean, huge, like 7-pound embers were flying through these winds miles away. And in these older homes, especially homes with raised crawl spaces, they would start a small brush fire, and then the embers and pressure difference would pull that fire into the crawl space through the vent. And then that house catches on fire. And that house starts a new spot fire. So that's why you see these fires that are really spotty. It's not, a monsoon. It's these ember fires that start and scatter throughout neighborhoods. And that's how these fires move so quickly.
Yeah.
So
exactly.
making your home safer from embers makes you much more resilient, in my experience.
Yep. So think like a log.
Think like a log. I like that. I'm gonna borrow that. Okay. Next up, what makes a home healthy? And Mariana, we're gonna kick this one to you.
Sounds good. Yeah, I think you guys are going to see that there's a theme here that there's been a lot more research and science put into buildings recently, but it is the construction industry as a whole is, has been slow to implement a lot of those things. And so taking advantage of some of the research that's out there already on things like Firewise Homes and what I'm going to talk about, healthy homes. There's a lot of information out there, and a lot of times it's about educating yourself, making yourself aware, and choosing an educated team that Mark mentioned, and I think everybody's going to mention at some point that your team becomes really important, your project team, whether or not they are willing to train themselves, learn more, and kind of push it towards that. So on the subject of healthy homes,
Mariana, just one reminder, we are interpreting live, so if you can just slow down a little bit, that will help them. I had to practice, so I understand.
I am high energy. It's very hard to speak slowly, but I will try very hard. One thing that you definitely want to think about when you're looking at rebuilding is the impact that your home will have on your health. I think there's been kind of a fitness revolution in the US, and there's been kind of an organic food revolution in the US. And I feel like there's this groundswell around the topic of healthy homes. It's kind of the trifecta of things that actually affect your health over a long period of time, to a degree that you probably don't realize. And if you think about how much healthcare costs in America, it's definitely something to consider. Don't think that's going down anytime soon, unfortunately. So one of the things that people don't realize is we are completely accustomed to living in unhealthy homes. If you have a forced air furnace situation, that means that air exchange is only happening when your heat is kicked on or when your air conditioning is kicked on. And that is a limited amount of actual ventilation. One of the reasons all of the panelists here today have used Passive House as our educational path is that as a standard, it requires continuous fresh air exchange. And the health benefits of that are just amazing. And I think there's a lot more research recently about indoor air quality and what kinds of things that can impact. And it's not just, a situation like Mark had in his house where he had minimal damage from the nearby wildfire smoke because of air tightness practices that he implemented. It can also be things like allergens, pollutions, but more than that, things created inside your home. Cooking creates particulate matter, and bringing new furniture in brings VOCs with it. There's all kinds of chemicals in your cleaning products. I know you don't want to hear all of that. However, it's impacting your health. So having that fresh air exchange is massively important. And the yin and yang of this situation is air tightness in your building envelope and the fresh air exchange. And the analogy we like to use in training is that the building envelope is like your skin, And the mechanical ventilation is like your lungs, and it's breathing for you. It's filtering that air coming in. We have up on the slide, no dust, no noise. Yes, please. So one of the big perks of high performance building and the Passive House standard is that people immediately feel the difference in the air quality when you go into a house of that standard. It's less dusty, it's not as noisy, and you're not dealing with allergens that you would have from the outside typically. The mechanical ventilation system that's used in really low load buildings or high performance buildings or passive houses is typically a little bit different than what you're used to. An ERV is an enthalpic recovery ventilator, and it's a simple piece of equipment that is basically 2 filters, 2 fans, and a honeycomb that passes outgoing air past incoming fresh air. And it actually, these machines have the ability to recover heat from that as well. So you can actually save on heating costs by using that kind of system. You can passively heat outgoing or incoming fresh air from 30 degrees to 70 degrees without any additional heat. So these kinds of approaches are really important to consider. The other side of that, and something that gets asked about a lot, is that with increased air tightness, which building codes have been encouraging over the years, should we be more worried about things like condensation and mold? And the short version is yes, they do come hand in hand. And that is another reason that mechanical ventilation needs to be designed in tandem with your building envelope. It's such an integrated process. The closer you get to high performance and to zero, you really want to have all of the aspects of your building integrated, and your team again, having the mechanical person on board ahead of time with your builder and your designer, everybody on the same page with those goals is super important. Do I have time still, Jessica? Okay, so a couple of other things that you want to keep in mind when you are starting to look at doing high performance or passive house level is the dedicated kitchen exhaust. So not combining an ERV system with the kitchen exhaust is super important because of all, as I said earlier, we produce through cooking, and you don't want to be pulling that grease and everything else through your mechanical ventilation system that is supplying you fresh air. Proper commissioning of the system is another thing. You don't want to pay money to have a system installed that then does not operate properly. And I'm going to wrap it up and do some answering of questions later. Go ahead.
Thank you, Mariana. I want to make a quick comment because I know we very quickly can land ourselves on a slippery slope of terminology that is not normal to most people. And I know one of the questions I saw in the chat kind of scrolling by is, we have jobs, we have lives, we have children. How do we keep all this in check? And your job is not to know these things as a homeowner. Your job is to think about these things as a concept. Do you care about how fresh your air is? And if you go to your team that you're going to work with that's going to help you and say, look, I really want this thing, then it's their job to help you do that. And so don't be too overwhelmed or feel like you have to become an expert today. You don't. This group has years and years of training and expertise that have brought us to a place where we can have these conversations. But think about the simple question and think about the things that you prioritize as you're thinking about rebuilding. We're going to go to question 5. why do materials matter? And Brian is going to speak to this topic. Brian, we paired you right after what makes a home healthy, because I think it is a continuation of things Mariana has introduced us to. And yeah, take it away.
All right, well, thank you. I guess I think I've been scrolling through the questions also, and there's some really great questions coming up in the chat window. So hopefully we'll have time to get to some of those questions at the end of this. And this is more of a kind of brief overview of everything, just to, like you said, Jessica, just to know what to ask your team for, and not necessarily to get into the exact details of what, how to accomplish those things. And I think for me, so my family, we lost our home in Marshall, and our home was one of a zero energy home. We had no utility bill. We had no gas connection. We drove our electric car for free. And it was a very healthy, wonderful place to live. And I didn't really appreciate it as much until I lost it. And now I'm in a rental with a gas furnace and no ventilation. And I can tell you, now I remember why I did what I did 10 years ago to build the house that we did. And so, I think when you're doing this amount of effort, and if anyone who has done construction, been in construction, it's obviously a lot of work, it's a lot of money, and it's, for most of us, our family's largest investment. And so to have a healthy space for your family and have another chance to be able to choose those materials is a really great opportunity. And I think that while it can seem, I think, overwhelming at the beginning, this is something that is chosen throughout the process. So you'll have time to make some of these decisions. And I think, as people have mentioned before, there's insulation choices, there's finish choices on the interior and exterior. But as you see in the slide here, when you're using natural, simple, it's just kind of like food, I guess, low embodied energy materials, those are often also very economical. And so if you know what you're doing with the design team, I think it's very easy to get affordable finishes that are also very healthy. And so, avoiding chemical paints. In our house, we obviously had, it was a straw bale lime plastered finish, so there was no paint in our house. And we did have some foam below grade, but above grade we had straw bale walls and cellulose. And then for our wood ceilings that we had, it was all reclaimed timber from basically forest salvage material that comes from Granby, Colorado. And so it was beautiful, it was simple, and it was also, very healthy material to have. And it gave it a lot of character as well, architectural character and a feeling of warmth and quality, even though they were very, per square foot, very economical materials to use. So, but, I think when you're living with those materials half of your life indoors sleeping, and this is your chance now and my chance to do this again, and I'm absolutely going to choose, sort of the same material palette as before on the interior for the reasons of health for my family and my children, my 2 children.
Thank you, Brian. I think the comment too that always sits with me is your children. It's not just your body that lives in this home and breathes the air in the home. It's your family, it's your parents, it's your children, it's your friends. And it's, I think there's an impression that these materials are exotic. They are not exotic. They are not cutting edge. They are materials we've been using for a very long time. They're very traditional materials, and they've been recycled or could be recycled. They are more connected to the earth than, a closed cell spray foam, which is, as Andrew said, like a solid state of petroleum. So it's definitely something to think about early in your project, and just know that you have choices more than anything else. You get to decide. There are choices out there for you. Okay, number 6, we're making our way through. Let's return to Mark. Take us through, what is a smart home really?
So I think I want to answer this by talking about my own personal experience with my home. I started off with a typical home in Louisville, built in about 1987, tract home. And when I purchased the home, I had to really, and I knew I was going to make modifications to the home, and I needed to make some sort of decision as to what sequence of events I wanted to prioritize, and also how it was that I wanted to modify the home to meet some of the requirements, or not necessarily requirements, some of the standards that we're talking about here tonight. So, and all of this melds in with like what Andrew talked about with Firewise, what Mariana talked about with a healthy home, what Brian talked about with low VOCs and material selection. And so for me, a smart home isn't about the technology that's in it. I mean, you won't find in my house, you won't find Siri or Alexa or anything like that in my home. You're not going to find a switch that I can turn on with my phone, or you're not going to find that I can call out to some unknown entity and have all my shades drawn and my lights turned off. What I consider smart about my home is what I started off with. So when I lived in my home before, it was incredibly drafty. You could sit next to my fireplace and a good stiff wind would come along and it would literally ruffle papers in my house. You could sit next to you couldn't sit next to any windows in my homes because there was frost on them, and you could literally feel cold air emanating from or radiating off of those surfaces. So for me, the smart thing to do was to peel off the siding of my house, attack those issues by adding new insulation, which what I did from the outside because I felt like it was more effective to do it that way, because I was addressing some other issues related to energy loss in the home by mitigating my thermal bridging, but also I could not take the drywall off of the inside of my house without incurring a lot of costs. So there was a cost component there, and I decided to insulate from the outside. But before I even did that, I air sealed the home. So when my house went through the fires, and I had a home across the street, unfortunately burned down from me, and I had many neighbors just a few 100 yards from me that lost their homes. I didn't have smoke in my home because it was completely airtight. And this was something that I could do at a very low cost. So I air sealed it from the outside, I insulated it from the outside, and then I added windows that were one of the sponsors for the CGBG, Elpin Windows, that gave me a triple pane window. So I had a Firewise protection there, but also I had a nice, smart complement to my insulation and my air tightness envelope. I did all of these things, and this can be applied to new construction as well, before I even considered what am I going to heat the house with? How am I going to ventilate the house? And the reason why I did that is because these things that were cost effective to do up front and easy to do up front. But then my planning continued on. I thought the next important thing was the ventilation, and because I've now air sealed my house, I need to come up with a ventilation and a fresh air strategy. So I added, I went ahead and I did something different to my attic space, which is I turned it into what we would call conditioned space. So I moved my insulation from on top of my drywall in my attic to the outside walls of my attic and to the underside of my roof, which created a space that I could put a ventilation system in. And then I could now condition my house with fresh air from the outside, filtered with a MERV 13 filter, so that when we had the fires and that was turned off, I came back into my house. I had a slight faint smell of smoke from just opening doors, walking into my house, I turned that ERV on, and within a few hours, I didn't have any trace of smoke smell in my house. This also, what I did by insulating to the outside of that attic space, I closed up all the ventilation spaces that were in that attic. So now I didn't have any places for embers to reach into my home. So that was a smart thing to do. It also got me ventilation. I have a much healthier indoor air quality than I ever did before. And then finally, the last thing that I was able to do, because I approached these things systematically by addressing the building envelope first, then addressing my indoor air quality. Now it was time to get rid of my gas burning furnace. And so I switched over to an all-electric furnace. There's availability of these that are one-to-one switch from a gas furnace to an electric furnace. And now I'm ready to take the next step, which is to offset all of this with my my PV system. So it's a very one-by-one step systematic approach to thinking about this. And the reason why, and I'll finish up with this, the reason why I did it this way is because now my PV system is right-sized. My heating and cooling system is sized appropriately. So I didn't spend nearly as much on it as I would have if I had switched my heating and cooling system first. And my solar system now can offset my house, but I don't have to have a gargantuan solar system in order to offset my house.
So just to recap, you insulated your house. We'll slow down. Thank you. You insulated your house.
I think Elena or Marina, one of you is now on the English channel, I believe, because we can hear you loud and clear on the English channel.
I'm going to keep going. Mark, you put a really good jacket on your house. Now you don't need as much energy to heat or cool it. You changed your electric system, which can be smaller because you don't need as much energy to heat or cool it. And then you went and after your renewables, which you didn't need as many solar panels because you had a really good jacket on and you didn't need as much power to heat or cool it. So,
yeah.
And I think that's what we're talking about in the beginning of this conversation is that all of these things that you do impact one another positively, and they have benefits in multiple categories. So the same things Andrew's talking about in Firewise to keep your home safe from embers and from smoke is what Mariana would tell you to do to keep pollution and noise out of your house, and what Mark would tell you to do so that you don't need a very big furnace. Thank you, Mark. Thank you for sharing that story about your home. And I'm really glad that you were fortunate to go home after the fire. I know it's not always something we get to control.
Absolutely. Thank you.
Moving on to number 7, perfectly timed. Mariana, windows, are they worth it?
So yes. I think I will try to take longer pauses between my sentences is what I'm going to do. Okay, guys. So windows are fundamental in the performance of the home, the comfort level you're going to feel, your ultimate health. I cannot stress enough how much the right choice in windows would certainly make or break a home going for Passive House level certification. But even in homes not going for certification, the windows can often have an incredibly large impact on the performance that you're going to experience. A code minimum window in climate zone 5, which is where we are, will not keep you comfortable in the sense that it will not keep you from feeling a temperature difference on one side of your body near the window to the other. In climate zone 5, in order to really address comfort and energy efficiency, we are looking at triple pane, thermally broken windows, 0.14 U value, R7, up around there. Obviously, not everyone can do that. I think the important things to take away from the window selection process, though, are that it needs to come up early. It needs to be given weight in your budget, and it needs to be in the context of whatever your goals are. I think a lot of people talk a lot about the glass and don't realize that the frame is actually the trouble spot. Window frames are a highly engineered item, and there is a massive difference between code minimum window frames and high performance windows that are available on the market. In the past, the United States has been behind European window manufacturers as far as performance, but really just in the past 5 years or so, that has changed a lot. In high performance windows at the passive house level, there are grades to the window frames. So there's A, B, C. When you have your designer and your consultant, your energy modeler, look at what type of window you want, they're going to be looking at the frame most likely. The advice we always give to builders on top of that is that due to the complication of window specifications, expect the most errors on that spot. Quotes, estimates don't necessarily reflect design specifications. Delivery might not reflect what was ordered. Just be on alert about windows. And you as homeowners, knowing your options early on is going to have a really big impact on that. So an effective window design, or an effective design that involves high performing windows, has the window doing a lot of different jobs. It's not just what you would think of as a window. In a very high performing house, for example, it's basically a solar panel. In climate zone 5, if you actually have higher solar heat gains, you can reduce the need for heating inside your building. All of this is designed, though, together as one product. Your building is, it's almost an organism. I talked about the skin and the lungs before, and that's how you need to think about it. It needs to be designed from the beginning as a compilation of a lot of different products. You don't need to worry about that. You need to worry about assembling a team that can do that. And that can be a daunting thing as well. And I think we're going to address that later. So I'll leave that for now. On the subject of windows, there are some things that you can think about from the homeowner perspective of design requests that will reduce or cost save a little bit on your high performance window package. A lot of that is things that were mentioned earlier by both Greg and Andrew and Mark, that consolidating your glazing in your design, not having as many window frames. If it comes to having 2-3 windows right next to each other versus one big window, that one big window is going to perform a lot better for the cost that you're spending on it versus the 3. Using fixed pane clerestory where you can, given the fact that you keep an operable window in every room, obviously, or in every main area. Avoid, like the plague, avoid double hung, traditional sliders, single hung, pivot. They don't perform well. They just don't. They just won't. They will not. High performance windows do not work like that. every time you have that pane sliding past another pane, it's an air leakage point, and it's a point for thermal bridging. So that's something to keep an eye out for when you're picking windows. And I'll stop there. Thank you, Jessica.
Thank you, Mariana. I think, you know, there's a lot of, and we're going to talk about cost, I'm sure, during the Q&A, of high performance buildings versus traditional buildings or code compliant buildings, depending on which code you're talking about, but just let's call it generically. I think windows are a bit of the exception. I think windows are where you do plan early to put a little extra money in your budget, and the payback you get from that is huge. I don't want anybody to have misconceptions. It's not that they are the same cost as a different thing, but it makes such a big impact in your home, in the resilience of your home, in the comfort of your home. I am sitting right now next to a window in an old building, and it is freezing. So
Can I add one thing?
please.
There is not necessarily a correlation between price and performance.
It's true.
Even when you get up to high performance windows and you're looking at windows that perform really well, there is a very big cost span in those. Some of that has to do with the marketing of the window agency and how well they do that. And some has to do with the materiality, you know, a very nice wooden frame versus an aluminum thermally broken frame. So keep that in mind as well.
Shop around. As an architect, I shop around for windows a lot. Brian. Brian's my window friend. Okay, let's move on. I'm gonna keep you guys to 5 minutes so we can get to Q&A for these last couple. Number 8, who are your biggest carbon culprits? Andrew?
Yeah, I'll make this really quick because I know we want to do a lot of Q&A, and there's a lot of questions all over the place. And I think, you know, especially if we start talking about carbon, it becomes kind of an existential question, especially if you're in the rebuild mode. But we also know that we are affected directly and specifically by climate change. And the existential question, the existential part of this question is what do buildings have to do with this carbon question? And so one of the great leaders, Ed Mazria down in Santa Fe, really got people's attention to the impact of buildings and carbon. And he was able to lay out and chart out the impact of carbon, the overall human carbon impact, and what buildings place in that through a lot of data resourcing, was that buildings essentially are around 40-ish to 42% of the carbon impact of humanity right now. So what we do here actually does have a real impact in the future of what the carbon question is. So like what we want to see is people maybe not individually say that I want to be a zero carbon person. And I've been in the field for a long time. I do not have a client who's ever brought up a low carbon building to me. And I'm sure that's pretty standard. But at the same time, that's the problem we have to tackle en masse and as a community. So the question is, why do buildings need to answer this carbon question? A, they're the largest impact. B, the carbon question is interrelated with the fire question, interrelated with the health question, the energy question, the cost question. All these things intermingle. So let's take concrete, for example. Concrete is probably the largest single carbon emitter of humanity in the world. Estimates are between 6 and 8%. That's well beyond the burning of gasoline, for instance, for cars, which is extraordinary. So what do we do on an individual basis? Concrete's also expensive. So to reduce carbon for our buildings and to reduce costs, why do we not have construction plans and engineering plans that reduce the concrete on site. It's a simple thing. Ask your engineer, ask your architect, why is there so much concrete on my building? Refrigerants is another question. We design inefficient buildings, and then we put high performance heat pumps and systems in them. Some of these systems have really extraordinarily large refrigerant systems in them. Refrigerants are one of the strongest human-made greenhouse gases ever devised. In fact, they're so powerful that we consider them a way to see if there's other spacefaring technologies in the galaxy. It's an extraordinary chemical. And so that's something that we can ask, how do we reduce the impact in the size of the mechanical systems in our buildings to reduce or eliminate refrigerants in them to create comfort? Foam insulation, and we went through a lot of foam. Foam is particularly sensitive to the carbon question. We use refrigerants, same kind of chemicals to expand and make foams. So from fire to carbon to performance, foams often are kind of on the B list or certainly not an optimal choice. And then the degasification. We have a lot of fracking in this community. We've seen what fracking has done to our air quality in terms of ozone. We're seeing methane plumes all over the planet due to fracking, essentially. And we want to degas our infrastructure. And we can start with our communities, and we can start our communities with our homes. So we're eliminating the gas line to your house, inserting heat pumps and building passive houses that don't need that much energy in the first place, and provide all these other kind of essential components of comfort and low energy. Really helps kind of answer the question or allude to what the idea of how do we reduce or eliminate the carbon culprits, because the homes that you're building now are going to be passed on to generations from now, and those generations deserve buildings that are zero carbon essentially in the future. So that's kind of one way to approach the question of carbon in our individual decisions in building homes.
Thank you. Number 9, how can you design with the future in mind? And Greg is going to take this over for us.
Yeah, interesting. You really designing with the future in mind is what we've been talking about all night tonight. So how do we future-proof against climate change? How do we future-proof against fires? And then maybe this category I'm going to touch upon right now is how do we future-proof against how we actually use and occupy and enjoy our homes. And so one of the things to be thinking about as you design a new home is, what you need to be designing for aging in place. And this is not really rocket science, but if you're thinking about those sorts of things, you want to think about placing rooms on the proper levels where they have access, or making other means of access to those rooms if they're on inaccessible levels. You want to think about making sure your kitchens and your bathrooms in particularly are sized adequately to be able to accommodate the extra spaces needed for accessibility. There's lots of minor details too, things about like putting backing in your walls at future locations for grab bars, having cabinets that are removable in places where you need to have roll under space, etc. Lots of details along those lines. You also want to think about not only your own personal needs, but maybe you'll have an additional family member or an additional friend or loved one join your family, and do they need some kind of special accommodations as you plan. Mark warned us about getting too carried away with digital versus analog technology, and I certainly support and agree with that. Start with analog and all the basic systems of your envelope, etc. first, but there are many really nice aspects out there of new technology. There's a bazillion things out there, but one I can think of in particular that I really enjoy at my new home is this ability to have apps that I can look at how much power I'm consuming on my house and how much power my solar panels are putting out, and watch that live and in all weather conditions. And that's just one of many things. Better air quality, etc., etc. Think about Brian talked about this and many others as well. We want to think about durable materials and quality construction, homes that last versus things that are flashy and temporary. And we want to think above all about beauty in our homes. Beauty in itself is sustainable. Beautiful homes are ones that are cared for greater. They're ones that are maintained, restored, have inherent value, and will serve many generations. And I often think of a nice analogy about this is think about the inherent beauty in a Quaker barn. A Quaker barn is one that might have been raised by the community, uses local materials, natural materials, is very simple in form and shape, but very rich in character and quality. And we'll stop there and leave time.
Thanks, Greg. So our last question is the doozy, and I think it's the most important question we're going to talk about tonight. Brian, we're hoping you can lead us through this. Are you ready to start?
Yes, I think, I have helped people after the Jamestown fire in 2003 and also the 4 Mile fire in 2010. So I've been on the designer end of helping people rebuild after the fire. And I've seen the challenge psychologically to go through it. And now I'm on the other end of it. Now I've lost everything that I've owned ever. And my family is in this place where we are absolutely starting from scratch on everything. And we're trying to decide what's best for our family. And we're also trying to learn new things, because while we had a zero energy home, we had a home that was very comfortable. In the area we live in, Marshall, we're not sure we're going to rebuild there, just trying to figure out what happened and what the source of the fire was and how we could be safe next time if we built there again. So we have a lot of unanswered questions, and it may take a lot of time to answer those questions. And we want to make sure that we wait until we're in a good place to make those decisions. But I think absolutely, having had a zero energy home, a passive house that was comfortable, we'll absolutely do that again. And I think we can do that at the same price as other comparable projects. And I truly believe that. And that was one of the questions that came up in the comments that I think this panel and the related jurisdictions, Louisville, Superior, unincorporated Boulder County, if we can work together to help the public get the best practices and distill some of this for the public, I think, everyone's working, everyone has a lot on their plate. Families that have been impacted by this, I know personally, we don't have a lot of time to work on these sorts of things. So I'm hoping that through this process that we're starting today with Colorado Green Building Guild, we can work together to help provide some resources to people to get them the easiest path to making the best decisions for their families and their loved ones and their pets for the future. So I think, the zero energy metric, the codes, while they may seem, I think, like they're going to cost more, in my mind, I don't think that necessarily has to be the case. I think it can actually be cost neutral, and it's a matter of priorities on what you want to spend your money on and what's important to you. And when you put quality and health and personal connection with your family and your neighbors at the forefront of that thing, and not necessarily a certain aesthetic that you might see in a magazine or, I think those priorities, when you really work those things out in the built design, you're going to get a better life experience out of the project. So that's really our goal. As my family works through this process, we're hoping to get just a healthy home for our family where we can spend quality time with each other and enjoy each other. And yes, we want no utility bill. Yes, we want comfortable temperatures in our house. Yes, we want to eliminate natural gas. Obviously, we're not going to put that back in. Or we didn't have it before. We won't do it again, just because Lawrence Berkeley Labs has figured out that that's the #1 indoor air quality pollutant in our built environment. So I don't think we need to rely on it at all. We can build an all-electric home at the same price. It might just take a little more thinking. And some of that thinking, I hope our community can do for everyone as a free service. because we have that knowledge in this group, in this community, and I think we can provide that for free. So that's my goal. And I don't know how we're going to do that yet, but I know even our panelists today here, we have an amazingly talented group, and that knowledge exists, and hopefully we can, in future presentations and pieces of literature and through our shared efforts and connections, we can make this a reality moving forward. And hopefully this fire can bring about some positive change and set some examples for how other communities might respond more quickly in the future, and help homeowners get on their feet quicker and at lower cost and to get a higher quality product. So it does take collaboration. It does take, the team that we need to have is, it does take a lot of knowledge, but I think some of that can come from things that are pre-established by the jurisdiction or by your potentially, in the building codes, and it can be given away for free. And so it doesn't have to be so complicated. And the pieces that are, that really cost money is just the construction and the permitting. Those things aren't going away. Somebody has to go build a real building, but the technical aspects, I think, really aren't that difficult to do, to create what everyone is talking about here. If you know what you're doing and you have the right details and you have the right products, it can be very simple and very easy for builders to do if they know the right thing to do.
Thanks, Brian. You guys aren't going to believe this, but I wanted to start Q&A at 7:30 and it is 7:28. So really good job. Thank you for your thoughts and for your time tonight. And I really look forward to the Q&A. Is always the most vibrant part of our CGBG events. Every single time I'm surprised by what comes out of it. So we're going to start working through questions that people have been sending us in the chat. I have a team of people that you can't see here putting these in a Google Doc for me, and I'm going to just work my way through as best I can. And the first thing I want to address, and we can all talk about this openly, if you have a comment on it, I think it's a really important one. I've been part of watching some of the conversations happening, hearing homeowners talk to builders, hearing builders quoted in news articles about the cost of this type of construction. And the numbers are all over the place. On one hand, you have people saying it's going to be this many dollars between these two types of things, and then you have somebody else saying there's no way it's going to cost that much. And I think Brian really started to speak to it, is that if you know what you're doing, if you have a team that has learned how to do this efficiently, it doesn't really cost you anything for most of it. But what do you and I know Mariana, you're on the front lines of this. Why do you think we're getting this vast array of numbers from these different sources? And do you think it's really that expensive?
Yeah, that's a great question. And the simplest way that I can explain it is that we are typically not comparing apples to apples. And it's as simple as that. There are so many factors that go into a building, from the team, the labor, the supplies, the location, the materiality. I mean, there's so many things that go into it that it's extremely hard to compare one to the other. And unfortunately, the way kind of our appraisal system and the realty market kind of works is that comparison. It's, I have this house here with this program, this house here with this program. Which one's more expensive? And it doesn't look at which one has high performance windows. It doesn't look at which one has a better ACH 50 blower door test score. As a recent home seeker, that frustrated me to death, going and looking at homes and trying to understand the actual difference between them. And I can imagine if you don't know what you're looking at, it's that much harder. So again, not to sound like a broken record, I think the best thing you can do is find a team that you believe in and that you have references for, that you have seen has done, they have done a good job. When you're getting quotes from builders, it's not just, what has their training been and their experience with these kinds of things, but I would also ask to talk to previous clients. One thing we mention a lot in builder training is there is a very high correlation between a clean and organized construction site and a high quality build. And you can tell a lot from walking onto a site that's chaotic about how good they're going to be at hitting their goals. And that has nothing to do with the quote they're going to give you sometimes. So, I know that everybody always wants the simple, what is the additional square foot cost to do this kind of answer. It's extremely hard to give. Even in the state of Colorado, building code baseline changes from one street to the next. So, if I'm looking at our own internal studies of cost increase on passive houses versus code houses, which code, it makes a very big difference. So what I would do instead is try to identify your own budget, what you can manage, and more than anything, your priorities for that budget, and then find a team that is aligned with your goals.
Yeah, that's very well said. Thank you. I think the other thing, I've been in a lot of conversations with our organization, our board, other building professionals, and policymakers, people trying to help the community. And to Brian's point, I think there's a very large effort and investment toward leveling up builders who might not have experience in high performance homes, like in the way we're talking about here. And to me, I always prefer a builder who's willing to learn and listen and try something new and get training and work with you. If a builder comes to me or to my client and says, no, I've done this way for 50 years, the first thing I think about is, what else have we done that we did 50 years ago that we still want to do that way? We've learned so much. The other thing that I think is hard, I just want to kind of unpack for you, Mariana, is, we see people making these cost assessments, and there are a million assumptions that have to be made in order to do that. So if you want that warm jacket that Mark put on his house, and it has a certain value of how warm it's going to keep your home in the wintertime, if you do that in closed cell spray foam, it's going to cost you one thing. If you do it in dense packed cellulose, it's going to cost you something else. If you do it with mineral wool, it's going to cost you something else. And you don't need to know what those things are, just that they're types of insulation and the cost range on them is so wide. And if you apply that to all of the decisions that go into a home, you have a lot of control to make a very high quality home without impacting cost significantly. Greg, I see you're unmuted. I don't know if you wanted to weigh in or if anybody else wants to make a comment before I go to the next question.
Sure. Yeah, I think with high performance homes, not just passive house, but high performance homes, you certainly spend more on windows, you spend more on insulation, and you spend more on air sealing, most likely, although much of air sealing just comes down to quality of care. But you oftentimes save on HVAC systems, if you choose the right systems, because your loads are lower. You also save on your solar panels if you are trying to achieve net zero, because your loads are lower. You also save on, if you're going geothermal, your geothermal wells don't have to be as big because your loads are lower. So I think all of those things need to be weighed. And I also think a lot of these features comes down to a value proposition between other features in your home, so a lot of people, nothing wrong with it, but highly value, a $70,000 range for their kitchen. And so, when you weigh that relative to these other things, what's most important to you too. So I think it's only natural that the cost of these things have gone down significantly already and continue to go down. You know, when Andrew built his home, getting that quality of windows was a real chore in the US, and it's getting better and better all the time and going to continue to get better. And just knowing and being comfortable with these systems, you know, it's so much easier and less expensive to do too. So
Thanks. Andrew, did you want to weigh in?
I was just going to say, I mean, we, as professionals, this is all we do is costing analysis. This is just the life of building. And it doesn't actually, high performances doesn't really affect costs. It's really the idea of materials costs. The engineer can have a huge influence. The architect can have a huge influence. There's all these kind of externalities, but I find that the projects that have the best costs are when people are happy and the owner is nice and people are enjoying the process. Somehow that seems to have more influence on costs for my projects than the cost of lumber, or, you know, am I doing a net zero, or how many solar panels I put in my house. It's a strange, this is kind of a strange perspective, I think, in some ways, but when people feel good about something, they add more to it. They put more of themselves into it, and you get more out of it at the end. Because often costs are not the first cost, it's the accumulative cost going through the project that often seems to be the most daunting part to control. So people feel like they're part of the team, you have a good team, and people are enthusiastic. In a weird way, that does have a direct cost influence, I think, at least in my experience.
Mark?
I'm just going to say team, 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 team.
Yeah.
If you really want to impact your costs, you develop that team soon and you work with that team. And that includes you. You are not a bystander as the owner. You are involved in that team and you are directing every part of that team. So if you want to see a different cost analysis from your builder for a certain aspect of your home, request it and expect it. And I think piggybacking on what Brian has to say, there are many things that can be done to impact cost or to impact performance that have very little, if no, cost adders.
Absolutely. Okay. Questions coming in. Which passive choices are the most important and best bang for the buck if we can't do everything? I'm going to rephrase that as what high performance or passive strategies, passive house type strategies are the most important and the best bang for your buck. If you unmute yourself, you are going to be called on. Brian Fuentes.
All right, I think this was in one of the slides that you put up really early on, and Mark, you talked about it, was corners, but yeah, simple shape, I think. And I know that to address another question that was in the comments earlier about HOAs, I think this is one of the most challenging parts of HOAs, because if somebody comes to me and says, I want a really affordable passive house building, I want a great performance, but I don't have a lot of money. And that's what I'm going to build for my family. It's going to be a very simple rectangle with a gable roof with solar panels facing south. And that's what we're going to make. But I think with HOAs sometimes it's challenging because they want to see a little bit more articulation, which can be done cost effectively to some degree with porches that are attached on the outside, or you know, landscape features, that sort of thing. But if you just start with the simplest, the idea that you want to try to live in the simplest thing you can do and only add complexity when you have to add complexity to the design, I think ultimately that will give you the most cost-effective product in the end, if you always try to keep simplicity and of the building as a core principle. I think that's the number one thing, because like Mark mentioned, corners cost money in construction and they also lose energy. So they're both bad for the budget and bad for performance. So the simpler you can make it, the better. And I think, and just having a compact shape, as we all know, you know, surface area to volume is a real key in cold climates. And it's good for people also, I think, also to understand without getting into the weeds, but a passive house apartment building is almost has the same exterior components as a code apartment building because it has very little surface area per unit that's exposed to the outside. But single family housing is the most challenging thing to do in energy efficiently because it has so much surface. You're the penguin that isn't huddling with the other penguins. You're the penguin out by itself in the cold, and so you have to buy that fancy expensive ski jacket because you're alone. And so that's the weakness. So if we could build apartments instead of single family homes, that would be a massive cost savings to everyone involved here. But that's beyond the scope of this chat today. We're realistically probably about building back all single family homes what we had, but
we'll see. I think the other comment, tagging on to the HOA thing, is that HOAs, like zoning codes and building departments, they are living and breathing things, and they are not easy to work with. I have worked with many HOAs, but if you want to have a conversation, there is a design board. Change the baseline. Have a conversation about that, because we are working off assumptions and within rules and parameters that don't make a lot of sense. And if they say you need 2 dormers on your roof and you say, but I learned about Firewise and why? We can have beautiful homes. I'm a designer, Brian's a designer. We can have beautiful homes that are simple and have clean lines and are very efficient and are cost effective. I believe that, truthfully.
Yeah, thank you, Jessica. Because I think it's not just, you might take, and that's a good lesson, I think, for people here you've worked with HOAs, every architect here has worked with HOAs. That is going to take maybe a little bit more time for you to get that value, but just like, dealing with your insurance company, you might have to fight a little harder to get the product that you ultimately want, because you want to pay for what's important to your family and not some external thing that doesn't have value to you. So if you learn, hey, these aesthetic things they want to make me do, not necessarily, they might not be good for the community from a Firewise standpoint, from a resilience standpoint, and it might also cost me more money. So if we can just have a conversation about that, maybe the HOA can, in the future then say, hey, we had these rules in place, but now we've learned that, we're living in a different world today. And some of these things that might have been, we thought were maybe important before, maybe aren't going to be as important now that we know these other things that we probably should be focusing on instead.
Yeah, and I've seen HOA guidelines that were published 20 years ago, 15 years ago, 30 years ago. Nobody's rewritten them. And it's time to think about it. Okay, we're going to move to the next question. Can a poorly implemented advanced code be worse than a conventional building code done well? I think we're all going to agree. And whoever unmutes first can tackle that answer. Nobody? Mariana, you were going to
That's loaded.
Anyway.
That's loaded, and this is not fair. No, it's loaded. I can see how that question can come up because of the fears, legitimate often, around moisture movement through wall assemblies and not understanding exactly how that works when implementing your tightness. I would encourage you to think about the cost of not doing it. There are a lot of intangible costs that you are committing yourself and everyone else who interacts with that house for the duration of that house's life. You're committing and locking in that house to that performance standard for the rest of its life, unless some substantial changes are done to it. And if substantial changes are part of the plan, if retrofitting it is part of the plan, that's an interesting strategy.
I'll say I've worked in building codes, that have pushed, I've seen energy codes progress over time. And what I've seen happen that isn't super productive for energy codes or high performance building is checking boxes in the easiest way they can without changing anything else. So when air sealing became a code requirement in California, and our values went up, they just stacked the cavity with closed cell spray foam. Now you've checked your boxes, you've met the code. It's not the most economic solution. It might not be even the best building solution. And that's where I see some codes driving solutions, not to a place where we would necessarily want them in an ideal way.
So code has often been talked about the bare minimum legal requirement. You're not stuck to code. Code is, you can almost treat code as a recommendation, but what else do you do as a bare minimum in your life? Do you buy the bare minimum car? Do you wear the bare minimum clothes? Do you eat the bare minimum food? You don't. And yet buildings are one of the greatest kind of personal assets and things that influence our lives. So we shouldn't think of them as a bare minimum. So code almost shouldn't even be a part of that conversation in some ways, outside of life safety, but like the energy performance and the health and the other things we talked about. In terms of green, code is not kind of the reference point we should talk about. And somebody just asked, like my brother or somebody pays a lot for his heat pump energy. And so like we can't have a house that we just say, okay, no gas, all heat pumps, and we build a code house. And somebody pays a lot in electricity bills. We still have to pay attention to the envelope system and build what Brian Fuentes built. That's the kind of world where we answer these questions, and code doesn't answer those questions. So I think it's the wrong framework, to be honest. When we talk about rebuilding something that you're going to live in, don't look to code as your measure, but look to kind of the assets that we talked about today, essentially, and ask those questions. It's about asking those questions. Is code going to answer these questions? Often it doesn't. So, that's kind of my take on code. I actually don't know what code is often because it's not relevant to what I design. So it's kind of a strange situation. Thanks.
Mark, did you want to add to that?
Yeah, I mean, to piggyback off of that, coming from the perspective of a builder, we have a vested interest in the quality of the product, not only because there's legal ramifications to it, but as our customer is a homeowner, and our product that we're providing them is the home, and we have a vested interest in providing them the best product we possibly can. And so very often we move so far beyond the idea of what code says about what we're doing, because we're just doing what we do that we think is best for our client. And so the idea that an advanced code being implemented improperly, that's really more of a question of the quality of the builder than it is a question of the quality of the code in place.
Absolutely. Thank you, Mark. That's like perfectly stated. Next question. Are there builders out there that understand a passive home or green home better than others? And what about subcontractors?
Yes. I mean, there is a lot of information out there. There's a lot of opportunity to learn about your craft. And I say craft because not all builders are craftsmen. And as an example, we take pride in the fact that we train all of our project managers and all of our personnel in this case, in passive house methodology. We find it to be very important in terms of meeting the customer's expectation of quality. And I'm not just talking about the quality of passive house. I'm talking about the entire quality of the home. That training has led our project managers to build better homes. So yes, there definitely are builders out there who understand it and can implement it. And the thing about that is that if they understand it and implement it and implement it on a daily basis, it's going to cost less for them to do it versus another builder. And, you know, I'm not going to take the politically correct or diplomatic answer to this, because I think it's very important that your team involves people who understand the methodology that you're building to.
Thank you.
Can I tell you the red flags demographically on subs? Just from training demographics, I would say that the biggest bottlenecks to trained subs and parts of the team that you're going to have trouble with, and this was discussed in chat a little bit. HVAC subs, unfortunately, have little experience with low load buildings typically. Framers, unless it's done in-house by a builder that has the air sealing techniques down or has a very good relationship with a sub that understands that, it's not typical sequencing. So, you know, 80% of your air sealing details can go wrong at the framing stage if you're not on board with that. And then it kind of gets a little bit less important, but still something to watch for. Any sub that is poking a hole in anything. So an electrician or a plumber who is going to come on site and poke a hole in your air barrier. That is something to watch out for. Again, this comes back to a good builder that's done this, has good relationships with subs, can give references and has worked with them many times before and has that all kind of set up on the communication front. And anyone can be trained. So there's always that. So look for the desire to be trained. Look for someone who wants to learn.
And I want to point one thing out, Mariana, that you talk about that I reference all the time is framing and framing sequencing. It's not that you're doing anything more. It doesn't take, it's just a different strategy. You're just approaching a problem differently. So the materials are not any different. I mean, you might use a different taper membrane, but like very, very small marginal difference. It's more about how that framing goes in and making it very easy to air seal something versus framing in a way that creates a very time consuming detail and problem. And that's where I think inexperienced builders inadvertently charge more or quote more because they're missing the early step.
And inexperienced designers design assemblies that are difficult to frame.
Yeah. Agreed. I'll take one for the designer team.
Can we step back on the design? You know, giving somebody a design that's really difficult to create an airtight envelope is that's front loading that problem, right? And so having somebody who's educated in the strategy of passive house, for instance, I think we talk about passive house a lot because it kind of covers all these topics we're talking about. But understanding that sequencing at the beginning and designing that into the basis of it, like my projects, I'm doing a low cost project, and Brian, I would love to hear your input too, about building something that's buildable. It's high performance because I gave them the ability to do it sequenced. Really, they don't have to solve problems on site that I gave them, that we're working together in a team-like way. And that means that we understand the importance of the airtightness. We understand how the installation system works and the window installation. All those components are part of the design. I know Brian, Greg, and I are kind of on that side, Mariana and Mark on the other side. And this is kind of that idea is that we all understand fundamentally that process and we speak the same language. And fundamentally, to me at least, is the training is the idea is that the person you're hiring understands that language. It can speak that language across the disciplines that are involved in the building process. And that's when it goes really, really well, in my personal experience.
Yeah, that's a really good point. We've put a little bit of impetus on the builder's ability to execute something, but there's a huge burden on the designer and the design team to be thoughtful about those assemblies and those connections and systems from the beginning. And I know Mark has talked about this offline, our ability as designers and builders to collaborate and solve problems together so that we are solving them in efficient and smart ways that make sense for all the trades, make sense with the materials we have on hand, and be flexible and work, collaborate, really work together and find the right answer. Okay. The question is being edited as I read it. How do you justify additional costs associated with going above and beyond existing building codes to meet higher efficiency building standards, health subsidies, whatever opportunities there might be to help offset or justify those investments? Brian?
Yeah, I think in my experience, and this is kind of a segue from the last question Andrew was talking about, but the passive house builders that I admire when I've seen at conferences or across the country have basically solved the energy efficient problem and made it cost effective to a shocking degree where I'm like, wow, they're really smart. I wish I could have figured that out, because they figured out how to do it at half the cost we were doing it. They figured out how to do it in half the time that it was taking us to do it. And I wish I would have thought of that. So there are definitely, I think if this was mainstream and we wouldn't even be here tonight, we would just be like, oh yeah, everyone's going to rebuild as fast as we can because we have best practices everywhere and it's totally normal. The trades, I have a lot of respect for people that work in the construction trades. If you've watched anyone who's good at drywall or anyone who's good at concrete, it is an amazing artistic and technical ability. And so, if you have the right people and you know how to do these things, I don't think there's a cost premium. I don't think there's any necessary it's a false kind of argument that's saying that, oh, if you increase performance, you're increasing cost. Because in my experience, you're decreasing your mechanical system cost. And in my experience, sometimes you're also, compared to houses of the same size, decreasing your total insulation budget. Like, for example, by going to all cellulose, which is a very low cost insulation per board foot. So if you do it right, I actually think you're going to get a more resilient product. And when the power goes out, I never worried about my house getting cold or pipes freezing. It didn't matter. The power could be out for days and my house was essentially the same temperature because my heat would rarely actually turn on. And so I think that the value definitely outweighs, the pros definitely outweigh any of the cons. And I think that the cons, the higher price that we think exists with the right team and the right amount of planning and foresight actually doesn't exist. It's a different product entirely that you're getting.
Mariana?
Yeah, I was going to mention time constant as well, which is what Brian was talking about, just the amount of time that your building will survive on its own without, or remain comfortable without any additional heat or energy being put into it. The other thing, darn, I'm going to forget now.
It's okay. There will be another reason to talk about the point you wanted to make, I'm sure. I'm going to go to the next question. And this has come up a couple different times, so I want to make sure we get to it while we have a lot of people here. Are SIP panels fire resistant and good for building a passive home? How do they fit into high efficiency building? So whoever starts this, please explain what a SIP panel is for the group and then have at it.
Sorry. So a SIP panel is a structural insulated panel. That's what SIP stands for. And basically what it is a panel of a structured product on sandwiching an insulative product. So in many cases, it's a 7/16 half-inch OSB or CDX or plywood product. And in between there is foam, and generally foam. And there's two different types of foam. There's styrofoam, and then there's spray foam that we've seen pictures of in this presentation. There are other types of SIPs. They're less well known and less mainstream. I believe there's a straw bale SIP out there. I believe there's other types of insulation materials that are being used. The most popular ones would be the foam panels. And I would say from a thermal performance standpoint, they're pretty good and can achieve a lot of thermal performance, but they're problematic from a Firewise perspective because of the foam. They're problematic from an environmental impact perspective because of the foam, and also especially with the foam panels, they can be more difficult to retrofit and to work with in the future. So I wouldn't say that, one of the things if you get into passive house, you'll know that they don't necessarily say yes or no to certain products, as long as you can meet the standards using whatever products you want to use. So you can certainly use them. But I think most of the people in this panel would shy away from the use of them unless they were some sort of alternate material to foam.
Andrew, did you want to add to that?
I was just going to say, no, I wouldn't touch a SIP board at this point, largely for what Mark talks about. They're also very hard to make airtight, and there has been a lot of rotting failures. So they're not often the best long-term solution to building. But in that vein, that idea of that panelized component system vein, almost all my projects are panelized projects. So there are quite a number of high performance projects out there. We have one going up in Colorado Springs that's panelized through a company, but I know at least 8 or 9 companies in the United States that make panelized high performance panels that kind of resolve all these issues that we talked about in this earlier conversation without kind of compromising the overall long-term benefit. And they do have the idea, and much of the idea of SIPs, and I do appreciate and admire the idea of having a building that's built in a factory and not built on site by unbundling loads of stuff and then cutting them and just attaching them there. So the idea that you could build a panel in a factory and assemble it on site and make it waterproof or dry it in, as we call it in the industry, within just a few days in Colorado is really pretty much the future. And we hope see a lot more of them. And we're experimenting with a number of companies now on how to make that happen, including that one of those companies that make it sound straw called Eco Cocoon, for instance. So there's a bright future in this. And so SIPs was kind of the baby steps into that. And now we're getting into the high performance language of that type of construction.
Yeah, there are a lot of exciting things happening in prefab or partial prefab construction oriented toward passive house. I want to pause really quick. I know we've thrown passive house around a lot. There's stuff in the chat to share about what passive house is, but in the most simple of terms, and actually probably everybody else in this group will say it more eloquently than I will, a passive house is a building standard that originated in Germany that says for every square foot of your home, you can only use this much energy. And there aren't a lot of rules. There aren't 100 rules. There isn't a binder of rules telling you exactly how to do that. It just says you have to make a very efficient building, and we're going to measure it and base it on these metrics. So the reason this group, I think, is drawn to that ideology is because there's a lot of room to make your own choices, but it's also something that you can track very clearly with metrics. And that's what we're talking about when we talk about passive house. What I find really generative about passive house is passive house solutions and thinking, even if you're not going all the way to a true certified passive house, which has a very strict set of metrics, but you can follow that path. And that is really, in my mind, the easiest path toward healthy, high efficiency buildings. Does anybody else want to just chime in really quick on a broad overview of passive house? Hopefully I didn't butcher it too badly.
Mariana, I think you should probably, speak to this, but
You want to try first? Go for it.
No, I don't want to.
Only I improve mine.
No, I think you hit the nail on the head. It's a performance metric. So the reason all of us here love it is that we can model to it, design to it, we can build to it, see that we built to it. And where some people get scared or put off by the concept of a certification, in my mind, the certifier is like your accountability buddy. It's like taking a friend to the gym and making sure you're on track, and you're only scared of that if you're not on track, right? So, and it's the only standard I know of. And the only, if there were a better standard, I would adhere to that. But this is the one that I know of that deals with health, indoor air quality, comfort, and energy efficiency. But people first. It's houses are for people. The planet does not need more houses. We live in them. We need to live on the planet.
Right. And I think in the context of, I think what everyone's facing with insurance and inflation and labor and material shortages, I know Katrine Klingenberg, I always remember her saying, carbon neutrality cost effectively. And I think the original passive house, like apartments in Europe that were converted, were old, if you can imagine, stone, very inefficient buildings that were, hundreds or thousands of years old. And they were basically wrapped in insulation. You added triple pane windows, and in those apartments, you got rid of all the boiler systems that were super complex and expensive to operate. And you put in just a ventilation system, and then you had basically no heating system. And so you got to this very low carbon, very comfortable home to live in. Whereas before it was drafty, it was moldy, there was condensation, there were probably rodents and bugs in your house. And now suddenly you've got this beautiful, cozy, airtight, historic building that has very low cost to operate. And so I think that's really our goal with Passive House, is not actually to make, it's the Tesla for the ultra wealthy, right? This isn't the $100,000 solution. The Passive House is meant to be the way forward to get it for everybody, so that everyone deserves and has access to a home that is healthy and, mold free and has fresh air and is, so this is really, I think this is a metric that is really based on affordability and accessibility to all. And, and so in the context of this, if anything we can do as the CGBG or as the green building community, if we can communicate to the public that, look, you can do this and you can do this affordably, that will succeed if we can do that. That's the reason, I'm here tonight, and I'm hoping to stay involved. I don't know how we're going to do it, but I'm hoping that we can do that one thing.
Yeah. So this year's building award went to Killian and his team, who did a certified passive house. He was carbon positive. Johnny, you can turn on your mic and tell us the details on the West Slope that they built with Habitat for Humanity. And if Habitat for Humanity can build a low cost, carbon positive, energy positive passive house, we can all do it. And I'm so excited for them. I know there are projects in Denver. Killian, you're on. This is cool. Hey, Killian, did you know you were going to be on tonight? You can unmute if you want to tell us about your project for a quick second.
Hey, hello. I didn't know.
Me either.
Yeah, sorry, I missed the last question there.
I was just talking about your project, and here you are.
Oh, yeah, with Habitat, we basically have built for the same cost as conventional construction. I will say that we're not Passive House certified, but we certainly would love someone who would offer that for the next build, because that's a standard that we've learned so much from. Yeah. But by focusing on local materials, which currently a local 2x4 rough cut lumber costs $4 versus $12 off the shelf. So we can build for the same price or less if we focus on local materials, and kind of like a lot of the comments have been talking about horse trade, and where we obviously spend more on insulation, but as Brian mentioned, like cellulose is the cheapest, like most carbon sequestering, most universal insulation you can use. So wherever you can use cellulose, you should, and that's been a big kind of secret to how we've been able to achieve high performance in a 12,000 heating degree day climate here, along with high performance windows. So again, just want to echo everything everyone's been saying on the panel. I completely agree with your strategies, and I think even in a climate like yours in the Front Range, which is a lot less than the demands we have, a lot of the same lessons apply for sure. And so I think if you do it right, it doesn't have to cost that much more, or could even cost the same if you particularly if you integrate with design build and find that team that everyone's been talking about. You can save a lot of inefficiencies if from the beginning you have a strong team that communicates strongly, and you don't spend time trying to figure stuff out when with people that aren't really on board.
Thank you. And remind me, so the project with Habitat is energy positive, carbon positive? I butchered the performance metrics.
Yeah, no, it's all of those things. So we actually have a metric for quantifying our carbon footprint. So it's actually carbon negative at term of occupancy. It produces 2 to 3 times as much solar energy as it uses in occupancy and usage. So similar to Brian, it's we have enough energy to build our homes next door. So our actual homes are solar powered for the next, and then also we have excess energy for EV power, and we keep about $30,000 to $50,000 extra dollars in our local economy by spending on local materials.
That's awesome. Thank you again.
And I should mention this is all done with volunteers. So just a point about some of the mentioning about skilled personnel and about how to teach people. I have found in my work that people with no experience learn a lot quicker because they just do what they're told, and people with more experience, it can be a bit more challenging, and you have to find the spot where they have personal investment in a new technology or a new method, and that can make all the difference in having a team that works for you or works against you.
Thanks, Kelly, and I appreciate it. All right.
Can I quickly just throw in that there is Mariana is part of this, is that there is a training and certification process, and basically it's a QA process that runs kind of throughout the design and building process. And on the professional side, there's a builder's training that Mariana heads through EMU. And EMU's website has a lot of resources Mariana can pick up on that now or later. And then there's also a designer's training, Passive House designers side of it. So that's kind of how those two worlds are linked together. And that's how we kind of learn that language between those two components. And then we should mention, there's also manufacturers. They're part of Passive House, and there's certifiers. So there's actually all the layers within the building process. There's kind of a Passive House touches. So I think that's kind of why you see maybe a lot of us integrated in it. Part of it is because we're part of that kind of larger process that's based on QA, quality assurance, and based on essentially physics at the end of the day. So all of us have to, at the end of the project, being a team project, we have to walk away and say, the building will do this. And we make great proclamations what those buildings do. So that's that QA process is throughout that. So I think that's, to me at least personally, very attractive to the Passive House kind of world, so to speak.
Thanks, Andrew. I'm going to ask the next question. It's over here in bold because it is important. And again, whoever unmutes, I'll let you weigh in. Can you speak to the level of energy performance measures that are being marketed and implemented by local production builders, such as Markel, Boulder Creek Neighborhoods, McStain, etc.? Specifically because many of these builders will be attending the Builders Expo next weekend. And are there any critical questions that we as homeowners can or should be asking? Thank you. What should we be asking these builders that they are going to be meeting next week at the expo? It's a loaded question.
There's a lot to unpack in that question.
We can focus on the end of it if we need to.
The questions to ask, I mean, a lot of what we discussed here tonight go into the questions that you need to ask, whether it's the production home builder or custom home builder, whomever it is that you're looking to engage with. You know, and some of that comes down to what's important to you. You know, what kind of materials are they using to achieve their energy efficiency? How are they, you know, maybe even to back it up, maybe even the more important question is how are they achieving their metrics, or how are they going to prove to you that they're achieving the metric that they say that they meet? So that's probably the first question, is how do they test and how do they provide that information to you as the homeowner?
Yeah, I would add that my biggest area of concern in typical production home builders is if you take a look at that contract, they're not liable for anything. And that can be a problem with especially the larger the production home builder, typically the less incentive there is for them to change their sequences, their processes, and hit those higher performance goals. You know, I don't want to lump all of them in there. There are some smaller production builders that try to focus on specific energy efficiency and healthy home practices. You know, and short of, you know, this is not a place to start naming names and picking out different builders at all, but everything that we've talked about asking them point blank what their training is, what their experience is, are they willing to learn more? Because anyone that says, oh no, I've got it, I've learned everything, I don't need to learn anymore, that's just crazy. I don't know everything. We've always got to learn
Panel
more.
would say that.
So, you know, the mentality, I think, is really important. And it can be tempting on the production home builders, because what they're very good at, and what I would love to see the rest of the builders get better at, is communicating that product that they offer. And I do believe that the buildings we create are a product. It performs to a certain degree. You need to let your team produce that thing for you. They're almost an industrial designer creating this product for you. And production home builders get that. They design their little product with a few different features that you get to pick from, which are really kind of superfluous and have nothing to do with performance. Yeah, that's all I'm going to say.
I will say, just in response to this question, we designed this conversation today and these questions and topics around starting a project, thinking about starting a project, deciding if you're ready to start a project. What is that going to look like? How big should it be? What, you know, like I said in the beginning, when you make a home, you make a million decisions easily. And there are no standard answers. And if you can go in just knowing that, you already know a lot. Large production builders are really good at streamlining things. They are really good at things that we need to get better at across the industry. And I think that there are a lot of opportunities for partnerships between people in this panel, people in the, you know, high performance building community, and these larger scale builders, where we all get better. And I really hope to see that happen. That's what I want to see happen, because I think that's how we get as many people home for as low of a cost and have better, safer, healthier communities at the end of this, as collaborating. CGBG is working on a one-page summary of his presentation, if you can believe that. It'll have the top 10 questions and a couple of the bullet points, very similar to what the slide said. We'll have it in hand at the expo, but it'll also be on our website. We might be able to email it to everybody that was here as a thank you, and here's your resource. And so that you can check in on those again. You can think on this, you can digest everything you've heard, and then start thinking about what matters. And what matters to you in your home is what you should be asking your builder, whatever that is. The next question, and it's 8:20, so we're gonna keep going for a little while. If there's anybody on the panel that does need to take off at any point, please, you have already provided us with so much of your time and thoughtfulness. So just let us know and we'll wave you goodbye. I'm gonna get through a couple more of these before we wrap it up for tonight. And then depending on how far this document goes, we can look at doing a separate Q&A follow up in a few weeks with this panel or another panel to answer miscellaneous questions that might come up after the expo. Can you speak to the high embodied energy of fire-resistant exterior siding, such as brick, metal, cement siding? Are those the best choices? Are there more environmentally friendly materials that are also fire resistant? What are our favorite fire resistant materials here?
I've used cork, which is a class B. There's 3 separate classes. Class A would be a cement board. Class C would be a wood, and then cork is a class B. And then the subs underneath of it using not letting air go behind it, but having against the wall with the cellulose or mineral wool. But in some ways, like that embodied carbon question, unless you do like you can solve one problem and create 5 more problems. So for instance, the concrete in the building, the steel in the building can completely overwhelm the insulation, can completely overwhelm all the other kind of carbon impacts. So looking at like, especially the outside of the building, I would definitely say beautiful is probably the most carbon impactful because it's something people would keep and maintain. So if it's something that people don't like or you don't like and you replace it after 10 years, that's not the best carbon solution. So carbon is the most complex of all questions. And in some ways, I think it takes a lot of deep thought to understand how those relationships work. And it's weirdly emotional in some ways. So, but steel's been really popular as far as like the ability to have different colors and patinas, things like that. And it's very much more contemporary now. Definitely the fiber cement products are getting better quality, and James Hardie is not the only manufacturer out there. There's a lot of other kind of solutions, especially architectural grade cement products that look pretty amazing. So I don't know if the other guys have opinions about that or not.
I think it's important to remember. I'm sorry, go ahead, Brian.
No, go ahead.
I was just going to say, and Brian, I'm thinking about one of your projects that I saw last summer, or I guess this time last year. But the fire resistive qualities of a building are not just the exterior skin. It is important. It does a lot of work for you. It is part of the expression of your home, but it's not the whole army in terms of protecting your home. And I'm going to let you build off this, Brian, but you know what we've talked about in terms of air sealing, and Andrew commented on mineral wool, which is a type of insulation that is very fire resistive. And balance, projects are all about balance. So Mariana, I'm going to steal this from you guys and from Enrico, but there are mice and elephants in every conversation, you know, and is your siding doing a lot of work and it's spending a little carbon, but it's doing a lot of work? And you have these other things that are doing work but causing a lot of carbon, and those are the better things to attack. You might not have a concrete free building, but you can have less concrete. It's all about balance and compromise in any project.
For sure. I think that's a really good way to look at it, because especially, you know, personally, having lost my house in a fire now, I'm a lot more conscious of this. And I think one thing I know that Andrew mentioned some really great options. I think stucco is one of those things that's very low cost per square foot installed, and it's continuous, it's monolithic, and it's pretty fire resistant. We had homes that we designed that survived the 4 Mile fire that were just monolithic stucco homes. And they, you know, one could, you know, if you want to be architecturally snobby about it, you could say they were boring or, you know, kind of whatever. But yeah, from a resilience standpoint and a cost standpoint, if you're trying to get value, that in my experience, that's a very low cost finish that has a lot of value. I know you were bringing up mineral wool on the exterior. I think maybe referencing our mass timber project that was a steel cladding, and then beneath that, there was a mineral wool insulation layer to keep that steel from getting too hot and then igniting the cellulose and the framing behind it. So that was kind of a composite assembly. But yeah, in this new world of extreme weather, I think the exterior envelope from a fire resistant standpoint is something that is worth investing some carbon in. And like you said, you've got to pick your battles, and if you want to save carbon, like Andrew was saying, really take a look at your engineering, your foundation design, get rid of the steel beams inside your building, substitute those for wood if you can. And then, your exterior has to protect you too. So, if you're going to spend a little embodied carbon somewhere, that might not be the worst place to do it if you have to use steel or something.
And something you said, I think is really important to point out. Buildings, we talk a lot about building envelope and building assemblies. The assembly part of that is very important, because a wall of a building, a roof of a building, any part of the skin of a building has many pieces and components, and they behave together and hopefully together to be stronger together. And so it's not just the exterior piece, like I was saying before, it's everything from start to finish. There's a comment from Bonnie, and I want to address it right now just because I think this is an important thing. It's something Brian and I talked about this morning. Bonnie, you say that there was a stucco home next to yours that blazed out of control right away. That can happen. There are, and Andrew, maybe you can speak to this, kind of to tack on to Firewise, or Brian, you can speak to this, but there are many variables in why that might have happened. It's probably not the stucco's fault. And there's only so much heat and so much fire any structure can withstand. There's a story I've told many times in the last month. Jay Leno talked about a car collector friend of his, associate of his, who lived out in California, this like beautiful collector Lamborghini thing. And he was in the hills and he knew he was at risk of fire. So he's like, I'm going to build a fireproof garage for my car. Great. They built this super engineered, super expensive concrete bunker. Sure enough, fire blazes through. He comes back to his property. The garage is intact. It worked. Holy heck. Here it is. And goes in the garage, and the car is melted to the floor. Just completely melted. So there are things at play that no matter how rich you are, no matter how smart you are, we can only do our best to protect ourselves from and be more resilient too.
And that's kind of the bigger question, is like, it's an individual approach, and we're Americans, we're kind of used to like the individualism in these frameworks of these conversations. But this is a community issue. And as you rebuild this community, you have to look at this within that scale. Because like I know watching Colorado Springs, we're doing a project down there, and the client's like, wood everywhere, wood everything. And we look at the Colorado Springs code is like, no wood anywhere on the exterior. They just said, forget about it, right? And what they saw was one house led to the next house, led to the next house burning. And that was the problem they were trying to solve. And so they saw the community scale of it. We don't see that often, and they did it kind of heavy-handedly. And this is a good 15 years ago when they implemented this particular code. But yeah, like think like a log, not like sticks. Part of the thing is logs do burn, but they're more resilient to smaller conditions, fire conditions. When you have something that overwhelms a community, Brian, God, man, we would love if your house survived and we could tell the story of Passive House being the ultimate fire resilient building, right? But we can't tell that story.
Yeah,
So,
no. I mean, it started a block from my house, and so all my neighbors' roofs were on fire, and it was blowing directly at my house. So essentially, it was a giant flamethrower at my house. We have one west-facing window, and I don't know how the fire got in. We did have a wood rain screen over the straw bale layer, and I haven't ever done that before for any other client. Every straw bale house we've done has always just been stucco, but we wanted to do a wood rain screen to get a little bit more insulation in the frame layer when we did our place. But what I do know about it is that at our house, and I wasn't really going to talk about this tonight, but our neighbor came back and was actually kicked out by the sheriff once. I won't say who it is, but getting in to try to look at their house. But our house burned standing for 5 hours, and the straw bale walls, you know, there was no firefighting, but they stood and burned till 5 o'clock at night. And we started, you know, it started at 11. So those are the 2-hour wall fire, you know, assembly with 2 inches of earth and lime plaster both sides. So the wall assembly was great. But, you know, we had a wood rain screen. We did have soffits that were metal, but I would assume that, you know, when the fire, well, my neighbors' houses were on fire and it was blowing at my house, it just got through the windows or it got into the roof or something. And, you know, and it was so hot, clearly, because I mean, everything we have was completely gone. We have the steel frame that our solar panels were attached to that's still standing in the concrete, but nothing else. So, you know, I said this in an interview I did for a film that Boulder County is doing on climate change, but I consider myself an expert in energy efficiency, but not in extreme climate design. And I think it, like you said, Andrew, it's not just an individual house by house design. It's a landscape design. It's a community policy and land use management strategy. I think when it was this dry for this long, we were all nervous in my community. We were hiking those trails, riding our mountain bikes on those trails, and we said it should snow, and it hadn't. And it was just bone dry for miles in the Marshall Mesa space. And so I think there's some unanswered questions on what do we do about that in the future, because these extreme events, I heard anecdotally that it was the driest year we've had since 1890 something. And so, you know, the conditions were ripe for this, and it's unfortunate, but, you know, I think it does go beyond the building design, and it starts to get into how we work together as a community to solve these problems. And I definitely am not, I have no idea. I don't know what we do when it's 100-mile-an-hour winds and you have fire and, you know, and you have miles of open space of grasses.
Yeah. We have 2 more questions. Oh, sorry, go ahead, Mariana.
I was just going to add another thing to consider with this is, you know, a fire that was as strong as that one, obviously it doesn't matter what kind of house you have, it's going to, you know, it's going to get to it. But there's so many houses on the edge of that or near that, and all of our houses are going to deal with smoke over the next coming years. It's going to happen. And so, you know, we need to have those community level discussions, and on a building to building basis. I think the thing that, you know, draws us all to this conversation is what can be done on a resiliency level. And that's where that time constant thing comes back in. And how do we, you know, I think it's pretty certain that uncertain events are going to happen. And the more we can kind of protect ourselves from that, get engaged in community level discussions to address things like sites and zoning and water usage and all of that, but also protect our own families by creating a house that's sealed well, controlled well, and will actually protect us from the current elements that we are dealing with, not historic elements. This is a new set of elements. Yeah.
Thank you. I will say, in 2017, when I was part of a very large urban wildfire, we lost 8,000 homes. We all said it would never happen again. We said, this is a 100-year storm. We've never seen anything like it. And nothing had ever quite happened at that scale before. And the year after that was paradise. And the year after that, another fire came to that same community. And I don't want to scare anybody, but I do think that we have to be very honest with ourselves that we can't trust that things aren't going to ever happen again. And I know that I want to live in safe communities. I pick homes and rentals and properties based on these experiences now. And you experience things differently because you've gone through this, and you pack a bag in your head way sooner than you would before you went through this. And that's the emotional part of this experience that I think is very difficult. We haven't talked about it a lot. Brian, you've talked about it a little bit in your personal experience, but giving yourself time and room to digest that and grieve this process is equally as important to everything else you're going to do as you decide how to move forward, whichever way you decide to move forward.
You know, I kind of just wanted to jump in here too, because we've been talking a lot about, we've been talking about a lot having to do with the rebuild, but you know, my neighborhood, there was one house that partially burned down. I mean, it's will need to be torn down the rest of the way. But all my other neighbors, they're dealing with all the after effects that we're talking about here. Their houses didn't burn down, but they're not living in their houses because they have, you know, depending on where they were located, they have smoke mitigation from tearing drywall out and insulation out, and basically rebuilding the inside of their house, to dealing with, you know, more surface level stuff. But then they found other things out about the construction of their house. Like, for instance, one lady had environmental testing come in for the fire and found out she had a mold problem. And, you know, and it's not, and I guess my point is that the impact of this has gone far beyond the houses that have been lost. And I don't want to diminish the people that have lost their houses, but you know, I take no solace in the fact that I was able to get back into my house sooner than my neighbors because I did these things. What I'm really upset about is the fact that my neighbors aren't there around me right now. I mean, my neighborhood is black. You know, at night there's no lights on because nobody's living in those houses. And but if I can take anything positive away from it, is that if you want to call it the example that I set in my neighborhood, I actually have received a couple phone calls from the neighbors to ask if I would be willing to talk to their builders and their mitigation professionals about what they can do to make their house a little bit more like mine. And I think that that's kind of like the message here, right? Is this is not going to fix the problem of the fires, but it is certainly going to help people be able to feel more secure in the future and understand things a little bit better.
Yeah, and not just feel more secure, but be more secure. You know, like in real measurable ways. I'll say my sister, had just bought her first home, 4 kids under the age of 10, lost their home summer of 2020. They've been trying to rebuild, working with their insurance company, and they're pursuing the build. They're a year and a half into pursuing the build, and they still don't know if they'll live in it. They haven't decided. And Brian, I know you have similar fears and concerns, and that's, you know, there are these really big, important questions that we can talk. I want to talk about and give people resources about how to build their home when they're ready. But also, I don't want to skip over the rest of it, because whether you lost your home or your neighbor lost their home or you were evacuated that night, like it's a massively traumatizing experience. And I've done it many times. When the fire started, I was in my car, I called everybody I knew, and I went straight into like, okay, here we go, because I've done it before. And I'm just very grateful that, you know, as many people that could get out got out, and that communities worked together to help each other. And, you know, there are a lot of things that we can be grateful for. It feels odd to answer these last 2 questions, but they're in my list in bold. So we'll do 2 more and then we're going to wrap it. For those who are left, thank you. There has been a lot of talk about having the right team. What are the major roles being performed in this team? And what sources, how do you assemble it? What are the sources for assembling that team?
Want me to take that?
Go for it.
Okay, so traditionally we are dealing with a designer or an architect, someone who is the point person on modeling or your building science goals. Sometimes that can be the architect. Sometimes that's another role. Sometimes that role is fulfilled by like a pilot program or other ways of doing things, but you need a building science lead if you have goals around building science you're trying to hit. Ideally, the designer and the building science part are communicating early. They are also communicating early with the builder. Builder is your point person for any implementation and brings all the subs onto the project, either manages them directly or has, you know, the ability to do that on team. If you can get those three together, you're doing pretty well. It's a lot for you to consider subs yourself. I know I've had homeowners in the past talk about DIYing, GCing their own projects, managing the subs themselves, thinking they're going to be able to get higher quality because they can vet each of those. That's a lot if you don't have experience with it, especially. Better to pick a builder that's got those relationships set up already. And again, you know, we've said it several times, but it's like a language. They all need to speak to each other. They need to speak to each other often and well, and the same language. Yep. Anybody have anyone they want to add to that?
I'll just say I echo it. From a homeowner perspective, you either find a builder you trust first, or you find an architect you trust first, or you find a team that works together off the bat. And you and your architect and your builder are the dream team, and you have to have a lot of trust and collaboration. And that building science expert can fit into that circle in any way. Sometimes the architect is bringing that person on, sometimes the owner brings that person on. And the rest of these things happen on your behalf by those people. They are there to protect you, to give you what you're asking for, to build what you're asking for, and meet the goals that you set for yourself and for your project based on the priorities you have. And you'll compromise. You'll go in with a big list, and you don't always get the whole list. That's okay. I can promise you, I've worked on houses with crazy budgets. There's still a budget. There are still compromises. And that's why having goals and having priorities for those goals and kind of what your values are is really helpful. And just trust that team once you find them to guide you through the rest, and it'll be okay.
You know, I mean, we keep talking about the team, and, you know, and Mariana, you always say it great with, they need to speak the same language. But one of the things that I find that is really important, whether it's our subcontractors, whether it's working with the architect or the engineer, is that everybody has this sense of collaboration and goal for that particular project, right? We are there in service of that project, but more importantly, in service of that client to facilitate that project. And so there has to be a sense of understanding amongst everybody that not everybody has all the answers to everything. So we're all there to learn to make that project uniquely what it's supposed to be. And that, as far as finding that team, that comes down to, you know, asking the questions about how do you choose to work? You know, how do you prefer to work? You know, I know from a builder's perspective, you know, we relish the idea and the opportunity to jump in immediately and be part of that team and to really collaborate. If your builder isn't of that mindset, or your architect isn't of that mindset, then you probably shouldn't be working with them.
Yeah, that is a red flag. I agree. Okay, the last question, and I think this is the right thing to end on. Oh, am I going? Johnny, which question do you want me to ask? There's one in bold, but there's one above it. Somebody want to highlight which one this one? Okay. Okay, we're going to end on this one. Excuse our live in real time. Do you encourage the use of prefab homes? There will be choices to make, but could some of the complexity and decision-making be reduced?
I mean, we encourage prefab homes for a number of reasons, but I don't know that I would say that the complexity is necessarily reduced. The advantages we see for our clients is that, you know, there's a shorter build time generally. There's more design time, you know, so there's that to consider. And also we feel like you get that there's a better product to be had for something built in a factory and not exposed to the elements. And there's a certain QC and QA that goes into those that we take advantage of, because if you use the right prefab company that understand passive house principles or high performance building principles, they've already certified certain aspects of their panels that make it easy for us as the builder to then turn around and implement that into your project.
Yeah, I would just add that, and I think I put it in chat earlier, it can be tempting to rely on a single product to fix a lot of things in your mind, and it doesn't. It just won't. I can call out examples for various aspects of the building envelope and the mechanical ventilation. There are some really cool, innovative products, and I include a lot of prefab panels on that are doing some really great work. And I hope, and I see that being the future of the industry, prefab, and also more offsite practices, which is maybe something you could ask builders too. Do they implement any offsite practices? Because that typically means a higher level of quality as opposed to site built, but it's still cheaper to build site built typically. And so, you know, you have to deal with costs, and it's not going to fix all the headaches. So just kind of making a blanket statement, I'm going to have a SIP house to fix all the headaches. It's not a thing. It doesn't substitute craftsmanship and understanding the building science.
I think there's also a misconception, or there are certain scenarios where prefab makes a lot of sense when you're in a remote location, or, you know, you have certain constraints where prefab makes more sense for you. Go ahead, Andrew.
Well, I just had a long conversation last night with our client down in Colorado Springs, and prefab is not simpler, it's different. And I think it's going to work great. And I would love to be able to report in March when we have everybody come down and watch the installation of the project and learn from it. And I think that we won't really know the answer until we start doing it more often. But I know that if you don't know what to do yet, make that choice at the very beginning. And you may not have to stick to it, but like, you know, they're not the same thing. Stick build and prefab are very different processes from the onset. So just make sure that you know what you're getting into before you really decide which path. So again, I think there's a lot of these conversations, well, a lot of hemming and hawing. Yes, this is best or that's best. And I know people want those kind of answers, but we're here to have the questions properly asked too. So make sure that you ask, is prefab the best at the beginning rather than halfway through the project or through the design phase, would be from what I have been experiencing.
All right, that we're going to wrap it up. Does anybody want to make a last comment before we sign out? Any last advice you want to leave these viewers with, or future viewers with, of these videos?
I just wanted to thank all the panelists and Jessica for leading us in this. I know you've worked some long extra hours to make this possible, and I just really thank all the participants for being here and taking time out of. If you're here, I know you're like me. You got thrown into this, and now you've got a whole new thing you got to deal with in your life. So thank you everyone for being here and contributing, and hopefully we can do more of these and dial in, like you were saying, Jessica, into some of the piece by piece. So I know this is not all digestible in one night. So hopefully we can do some good follow-up events, and thank you everyone.
Thanks, Brian. Okay, with that, thank you, Andrew, Mariana, Mark, Greg, Brian, I am extremely grateful to you guys making the time. I know that it was a bit of a whirlwind to put together. I really want to thank Michael and Frank and Johnny and Shiva and the rest of the team in the background that made this happen today. Robin, our admin, we have one part-time employee at CGBG who keeps us, I don't know, alive. Thank you to her. She's the one who sees your emails first. Please be kind to her. And again, we are a group of volunteers. So if we take a little bit of time to get back to you, we are doing our best to help everybody. So thanks again, everybody, and take care. Good night.